friends, back with me again, Ajigo Tamaputrada. I am your lecturer for Parallel and Distributed Systems. We have reached our 11th meeting about shared memory model or FREP. In our 5th video, we are going to discuss about lock, acquire, and release. What is that? Let's start our discussion. So in the previous video, we had one problem on what problem is that. It's called race condition, and why does it happen? Because here when it prints incrementing and it goes to sleep, and then it actually increments the number and prints it, it can be interrupted by another thread. For example, here decrementing, and when it is interrupted by decrementing, it provides the wrong value. So what we need here is to lock the process starting from here until here. We should lock this, and by locking this, other processes are blocked. Other processes are blocked. And by locking, there is a locking process and a unlocking process, and the locking process is called lock acquire, and the unlocking process is called lock release. So we will create that program. So this is the program that uses lock acquire. So what do you need to create this program? First, you need to import the lock from threading. So inside threading, there is a library called lock, and we import that. And then we create a variable called anything you want, but it calls the function of lock. And here, before you enter this critical section here, you write lock acquire. And then when you are done, you write lock release. And this is also done in the documenting. So documenting can also be interrupted by the other program, so it also does the same thing. Here, this is the critical section, and this is the lock acquire, and then this is the lock release. And what is the result of the execution? Let's see. So here we can see this is a very neat execution here. When it says increment, it increments y, and when it says decrement, it decrements y. Increment 1, decrement 0, increment 1, decrement 0, increment 1, decrement 0, increment 1, decrement 0, increment 1. It means that between incrementing and actually incrementing the value and printing, there are no interruptions made by the other thread. So this is what we call synchronizing with lock, acquire, and release. And what is the detailed process that happens here? Let's discuss further. So why aren't there any interruptions in acquire and lock, acquire, and release? Here is an example. For example, incrementing goes first. It then runs lock acquire, so lock is now uh, held by incrementing, and then decrementing goes second, and then it also wants to acquire lock, but because lock is now in the hands of incrementing, when incrementing wants to acquire lock, it is blocked. When it is blocked, it doesn't continue to uh, the next program. So until when is it blocked? Until incrementing declares lock release. When incrementing says lock release, the block is then become unblocked. And now if incrementing wants to use lock, it is then blocked. So just like that. And it is released when decrementing says lock release. So that is the process of lock acquire and lock release, and that is why none of them are running at the same time when they are in this critical section. And that is the end of video 6. We have discussed about lock, acquire, and release. And in the next video, we have still other synchronization processes to discuss. Thank you for your attention and goodbye.